Hello everyone, hope you all are doing well. So, today we are going to do topic 24 of paper 2, and here we are going to discuss mass selection. We have discussed pure line, pedigree now in previous lectures, and today we are going to discuss mass selection. So, what is mass selection? It is a method of crop improvement in which individual desirable plants this is individual desirable plants are selected on basis of phenotype from a mixed population. After selecting, their seeds are bulked and used to grow. The next generation. So this is what positive mass selection. So here we what do? Here individual desirable plants are selected on the basis of phenotype or from a mixed population. Their seeds are bulked and used to grow the next generation. So through this we can get our desirable variety. So this is positive. Now what is negative? Sometimes what happen? Only undesirable off type plants are removed from field and rest are allowed to grow further, This is negative mass selection, because here we remove undesirable of types, but in positive we get good variety through selection from mixed population. Here we are not removing or selecting, but here we are removing the undesirable of types, but here we are selecting the superior types. So this was all about mass selection. Now moving on, what are the advantages, merits of mass selection? What are the advantages, or you can say merits, or you can say applications of mass selection? The first one is, it is the good method for improvement of old varieties and land races. It helps in improvement of old varieties and land races, used in purification of improved variety, used for purification of improved varieties. More stable in their performance than pure lines. These are more stable than pure lines. Provide good protection against disease. Diseases. Simple and quick method of crop improvement. Takes only around 8 years. But when we go to pedigree method or other methods, we have studied in previous lecture only in pedigree method that it takes around 14-15 years. So it is quick method, takes around only 8 years. applicable to both self and cross-pollinated, applicable to both self-pollination and self-pollinated crops and cross-pollinated crops. However, only in cross-pollinated and less in self-pollinated, but applicable to both. Self-pollinated crops such as oats have been, while in cross-pollinated you can see crops such as maize, pearl millet, mustard, cotton, sorghum, etc. So you can add this in achievement also. These new varieties of these crops have been improved through mass selection. Now moving on to the next topic, because this was asked in previous years, so it becomes important. Applications of mass selection in self-pollinated crops. Application in self-pollinated crops, that is application of mass selection if in self-pollinated crops. So it majorly has two applications. First one is improvement of local varieties and second is purification of existing pure land varieties. So first we will see improvement of local varieties. Improvement of local varieties. So mass selection is very helpful in improvement of local varieties. Eliminates poor plants and improves performance and variety. It eliminates poor plants. That is, we discussed in negative mass selection. And improves performance and variety uniformity. And improves performance and varieties uniformity. It helps to keep variety uniform. It is also useful in it because it improves local varieties. It improves local varieties without adversely affecting its stability and adaptability. Because new variety will be made most of superior plant types present in original local variety. How? Because it not adversely affects its stability and adaptability, because the new variety is most made up of superior plant types only of local varieties. So as it made from the superior types of local varieties, so it doesn't affect its stability and adaptability. As the local variety is more adaptable to that region, the new variety will be also more adaptable to that region only. So I hope you understand. Now its second application is purification of existing. Let me rub it. I hope you understand, all of you hope you understand this. Second is purification of existing pure lines. Existing pure lines. What happens after some time? Pure lines tend to become variable. We have discussed when I was teaching pure line in the previous lectures, so you must see it, very important. Because pure line tend to become variable due to many reasons such as mechanical mixtures, mutation, natural hybridization or natural crossing, so when here as they become variable due to mechanical mixture, mutation, natural hybridization, so here the purity of pure lines is maintained by mass selection. Also, nucleus seed of pure line is produced through mass selection. nucleus seed of pure line is produced through mass selection. Also selection of desirable traits in secreting population. Mass selection also helps in selection of desirable traits in segregating populations. For example, you can see it in seed size of seed. For example, for seed size in oats. So I hope how is mass selection applied, how is mass selection helpful in pure line selection or cell pollination crops. So that is all for today. For any queries, do comment. If you like it, please press the like button. Do share and subscribe. Keep making notes, because most of the questions will be directly from the notes. Almost every question will be directly from the notes I am teaching, than notes from the topics I am teaching here. So that's all for today. Have a nice day. Thank you.